Well, as luck would have it, I go to test my tubes and my tube tester fails. So this is the Heathkit Model TT1, and in their day these were pretty decent tube testers. Unlike a normal emissions tester, this one does mutual conductance, and what it does is it can apply up to about 245 volts to the plate of the tube, and it'll also put a 5 kilohertz drive signal into the control grid and kind of put the tube under simulated real world conditions, we'll call it. It's still not as good as some of the more modern testers or some of the more advanced testers, and it's certainly not a curve tracer, but it worked pretty well. And usually the transconductance that you measured on here, once you use the multiplication factor, it came out pretty close to what the tubes actually were as far as their GM. But of course, this one has contracted the infamous meter problem. And the problem that happens with these, there was a newer model and an older model. The newer ones, like this one, used a Simpson meter movement. The older ones used a Weston movement, but they all had the same circuit in them. And inside the meter movement itself, there's 4 diodes for bridge rectifier for the DC mode, and then there's like a shunt resistor in there. And the resistor burns up, and sometimes the diodes would fail. The issue is, in order to get into that to fix it, you can't just pull this meter movement out. You have to take this funny looking curved bezel out, and it's mounted in from the back. And in order to do that, you have to completely gut the machine to just about to get to it. It's a really messy job. You have to take the roll out of it, and it's just a pain. And then there's really not much documentation as to what resistor you put in there. You kind of would have to experiment. It will read, but it won't read accurately, and that's what happens. What you'll find is that gradually over time, the meter will start reading lower and lower mutual conductance. It won't be correct. And you'll go to calibrate it, and eventually you max out your calibration pot inside, and it won't calibrate anymore. And that's what's happened to this. And it's really kind of, you fix it or you really can't use it. So I don't know what I'm going to do with this. I know it can be fixed if somebody has the time and patience to do it. I may just put it up for sale. I may just put it on the shelf. I don't know. I have a couple of emissions testers, and they're good enough to just check to see if the tube's working or not, or shorted. But I kind of liked having this for kind of doing some basic tube matching anyway. Anyway, plan B, I have 4 brand new, a matched quad of these Tungsol reissues made in Russia, 7591A. They're very good tubes. These are the same kind of tubes I used on the ICO ST70 project, and I was really pleased with how that turned out. So I have these 4 here. We're going to put them in, and we know that they're matched. They just came in, so everything's good with them. And, well, we'll put our other tubes aside. I know there's a lot of good tubes in that box, but without being able to really check them to make sure they're at least somewhat matched, I kind of am a little reluctant to use them. So I'm just going to use the new ones. All right, so maybe this will be a future video, or maybe you'll see it up for sale on eBay. I don't know. Okay, so I have everything pretty much tacked back into place where it belongs, all original. So nothing's replaced other than we cleaned the transformers, painted them, put them back in, and we redid the power cord and the power switch, and that's about it. I'm going to eventually replace these little 7-watt resistors because they get quite hot, with some nicer 10-watt versions, like that. And I'm going to replace the diodes, and I'm going to replace these pots eventually with some better quality ones. But before I do any of that, I want to make sure that I have approximately 48 volts on this bias circuit, because if you look down here, you have these four 12AX7 filaments all in series here. So if you add those up, 4 times 12 is 48 volts, which is, they're calling for about 40 volts up here. So it should be somewhere between that 40 volts and 48 volts in here. And up here, we want to see our 438 volt B+. So this meter here is looking at the voltage across the filaments, which is your cathode voltage of your output tubes. And then the meter up there, which is kind of off screen, is going to look at the B+, and I'll just let you know what it is. I'm connected up to the variac, and we're going to come up, and I'm monitoring the current on the variac as well. I'm using my B&K 1655 because it's up out of the way. So let's get started. So let's turn the power on to the amplifier. I think that would help, don't you? All right. So here we go. Okay, we right now have no voltage. What is wrong? I'm getting no voltage. All right, let's check it out. I'm getting nothing yet. Okay, we had a little wardrobe malfunction here. I didn't have the power cord plugged in all the way on the variac, so oh man, this is one of those days. All right, so let's start coming up. Now we're getting voltage on our power supply. So I have about 110 volts DC on the B+. I'm going to keep coming up. There's about 175 volts. And there's negligible current. 250 volts. So I'm going to let it sit at about 250 volts for a little bit to see if we get any kind of cathode current whatsoever. And it is, you can see, starting to creep. The tubes are warming up ever so slightly. Of course, we don't have full filament heat either, but it's starting to conduct. All right, let's bring it up a little more. Let's go to 300 volts. And there's 300 right there. And that's coming up just nicely. And now our voltage is dropping. We were at 300, now we're down to 275 again. So let's bring it back up a little more. And this is still creeping. And we're drawing, from the outlet, we're drawing just under 1 amp. We're at about 800 milliamps right now. All right, let's go to 350. And you can see that's coming up real nice. All right, let's get full power. And right there's about 403. About 410 volts right now on the primary, on the B+, and you can see we're running about 45 volts, 46 volts right there on our filaments, which is good. So everything is working as advertised. All right. So right after I shut the camera off, I go to take a couple of final measurements because I want to do it before and after and just take some measurements before I change those resistors and so forth. And I turned the amp on without the variac. In other words, I didn't just power it up slowly. I powered it up normally, like you normally would. And everything came up for about 2 seconds. And then I heard the transformer get kind of loud, start buzzing a little bit, and then the fuse popped, and a little puff of smoke, and that's all she wrote. Now, I haven't checked it yet, but My suspicion is that one of those little diodes shorted, because those are not the correct diodes for this job. So we're going to just take a look and see. I think you can see up in the corner here. See that one? Nope, that one's good. That's not dead shorted anyway. How about this one? And there it is, dead short. So again, I'm not surprised. And the fuse did the job. Now, a little word on that. Any of you that build a dim bulb tester, and most of you know what that is, where you use the light bulb and you kind of put that in series with your power outlet. This is my dim bulb tester right here. And if you notice, there's a switch for full and bypass, you know, all that. We all know what that is. But I also put a fuse in there, and this is a secondary protection circuit for me. And I'll change the value of that fuse based on what I'm servicing, so that even when I turn the dim bulb off and go to full power, this fuse is going to go hopefully before I damage whatever circuit I'm working on. And that's exactly what happened. If I can find the fuse that I had, I will show it to you. So yeah, pop the fuse. And again, I wasn't surprised. These are not very good for these types of things, because you think about it, you have these 200 microfarad capacitors and you have a very large inrush current. There is no inrush current limiting on these amps. So even though these are rated for 1 amp at 1,000 volts, they really can't handle any kind of consistent amount of power like that. And the surge current, when you first turn this on, the inrush is much higher than that. So these are going to fail. So I'll show you what I'm going to use in place of them. Now this is a diode. Even though it looks like a transistor, notice it only has 2 pins. This is called a Hexfred diode, Hexfred. And they are very fast acting diodes, so they're very fast. They can handle high surge current. And this one here is good for, I think, 1,500 volts at 6 amps. So these are quite a bit more substantial, and they work really well as rectifiers in tube gear. So this is what we're going to replace it with. Anyway, let me get to work, and I'll be back as soon as I get those components changed out. Okay, so here's another good example of kind of how things can go sometimes. If you look on this schematic here, or actually look at the actual amp, we have this little capacitor here that I've actually clipped out. We're going to remove it. And it actually went, let me tighten this up. And it actually goes from the junction of the 2 diodes. So if you look here on the power supply, you have these 2 diodes here. It actually goes from the junction of the diodes to ground. So it's basically bypassing this one diode right here. And it's not on the schematic if you look. Now, here's the thing. There are 2 sets of schematics for this amplifier, and it's dependent upon the serial number. Now, on my unit that I have here, the serial number of this unit is 12432B. And so this is the serial number range that this manual is for. This is the earlier manual. However, if you go to the newer serial number, which starts at 20,001. By the way, I'm trying a new experiment. I'm going to use this light green colored paper to see if the lighting is better, because what happens with these video cameras is when you use bright white paper, it messes with the color balance and everything, and the paper ends up looking kind of brown and dark looking. So hopefully this will make it a little better. But anyway, back to this. If we go to the power supply on the later one, lo and behold, there it is. And you can see that it's there. So this is another example of, even though this amplifier is an earlier model, it doesn't mean that you won't have some of the mods from the later models. So whenever you're working on one of these amps, not just Fisher, but all of them, we saw this in the Sansui 9090 video, you always want to get all of the schematics available for it so that you can kind of, if you get thrown a curveball like that you're not sure, you can look at the other schematics and you'll find that those are later revisions and they may have been added even though this is an older serial number. So I just thought that'd be interesting to show you. Okay, we're moving right along here, and what we're going to do is we're going to replace the AC balance pots. And this is a special potentiometer. This isn't just a normal one that you buy normally for volume, because if you notice in the back, if you look inside, there's like this plastic, real thick plastic insulator that the shaft is connected to. They all have that, but this one is actually a little bit extra. You can see this little plastic covering in here. This potentiometer is actually insulated for up to 500 volts DC. That's very important for that AC balance pot, because if you look up here in the schematic, you actually have B+ power coming straight into the top of the pot, and that's actually adjusting the AC voltage on this tube right here on this anode. So you definitely do not want to use a normal pot in there. Now this one is much heavier duty. It's a wire wound instead of a carbon potentiometer, and it is designed for voltage like that, whereas the ones that come originally with it are normal carbon track pots. They do have plastic inserts in them for insulators, but they get kind of noisy with time because of the carbon and all the voltage on them and so forth. So we're going to replace this. The one problem is where they drill the hole for this little lock pin. So this pin kind of goes through a little hole in the chassis, and that keeps it from twisting even if the nut comes a little bit loose. And the problem is they drilled the hole on the opposite side. So the hole would be over here, whereas the pin on this one is over here. So we need to flip that around. If you ever need to do that, because sometimes this happens, all you need to do is kind of pop open these tabs, just like this. I have 2 of them done already. You kind of bend them back, and you just carefully lift this up, flip it around 180 degrees, put it back down, and now you can just bend these pins back over, which I will do off camera here, but I'll kind of show you. You just bend them back over, and there you go, and that reverses it. So let me do that. I'll get them installed and then I'll show you. Okay, the deed is done. So let's go over all the changes that we made here. Starting with the very beginning of the power supply, you can see I removed the burned up diode, the shorted one, and I replaced it with a couple of hex FRED diodes. Now hex FRED diodes, number one, they have a lower forward voltage drop than a regular silicon diode. These are only about 300 millivolts to 350 millivolts forward voltage drop. The other thing is, compared to a normal diode, they have much faster recovery time and much faster switching time. So what that means is when this diode gets backwards biased, it's going to shut down much faster than the other ones. It also deals with high current surges much better than a regular diode. So the inrush current into your capacitor bank, which 200 microfarad caps, is pretty substantial on these tube amps considering how much voltage there is. So this is going to handle that with no problem whatsoever. I mounted them on this little perf board here, this little project board. You can get them like this just online. And then wired them into the socket the same way. Now, if you recall, there was a little capacitor, this one down in here, and the purpose for that capacitor was to prevent parasitic oscillation at high frequencies, because a normal diode, the type of diodes that were originally used in this amplifier, had a much slower rise time and shutdown time and so forth. And it would cause, every now and then, right at that transition when it was turning on to turning off and back biasing, the diode could actually set up kind of a resonance situation with the coil, of the actual secondary of the transformer, and you'd get an oscillation, a high frequency oscillation. It'd just be a quick little pulse, but it was pretty bad. Now, again, on the original schematic, it's not in there. You can see it's not located. That little capacitor actually belongs right here. But if you go to the later version, you can see they added it. Now, the funny thing is, again, like I said earlier, this version of amplifier is the older serial number, so it should be without it, but this one had it. So that means this must be a later production. In the production, they added it before they changed the schematic. So anyway, with these hexfred diodes, there's a high probability that that would not even be an issue, and we probably could once again eliminate it. But just for good measure, I ended up replacing that capacitor with a really high quality orange drop, and I did mark the outer foil. And the only reason I'm concerned about it this time is I want the low side that goes to ground to be the outside. This actually goes to ground. Remember, this is high voltage on here, so I don't want high voltage on the outer foil of the capacitor. Again, this is just added safety. Probably we could eliminate it with these diodes and we wouldn't need it, but that's okay. Next thing we did was we replaced all those bad resistors. If you recall, over here and over here, they were really getting overheated. You could see signs of, heat stress. These were little 7-watt resistors. I replaced them with a 10-watt over here and a 12-watt over here. That was based on availability as well. I couldn't find this 500 ohm. 470s you could find all day long, but a 500 ohm, the closest wattage I could get was a 12-watt, which is no problem. Actually, I prefer it because this is in your bias circuit on the cathode, and you really don't want it to vary with temperature very much, so that should make it even more stable. In addition, by going with the radial capacitor, this is a 105 degrees C capacitor, and I moved it away from the hot resistor, so you won't have to worry about the resistor cooking the capacitor. Moving forward in the circuit, those 200 microfarad capacitors, they were kind of a strange pair because this is a single capacitor and it's fully isolated with this paper can around it. And by the way, this cap is still good. It measured really well. And then the other 200 microfarad was right here, and it was an odd character because it had a 200 microfarad at 250 and there was a 40 microfarad at 500. So this was a really odd capacitor to replace. So here's what I ended up doing. I got two identical capacitors, and these are 220 microfarad, which is very close to the original 200, so there's no problem there. We don't have to worry about the transformer or anything. The capacitance is almost the same, and they're identical. And I wired them individually like this, and the circuit is exactly the same other than that. Then what I did was I replaced this can up here, which the caps were pretty good on those as well. Probably could have left them alone. But instead of having a 3-section cap, I went with a 4-section capacitor. I was able to find one, but there was one really bad flaw that I totally missed when I ordered this. I went and installed it anyway, but I will show you when we flip around what the problem is. It's not the end of the world, but it kind of ticked me off a little bit. This resistor got really toasty, and if you look at it, you see it's red, and that looks like black, which would be 22 ohms. But when I looked in the schematic, it's actually a 2.2K resistor. So I got the meter out because it looked really bad. And let's see here. Put this in there. And if you hook this thing up, it's reading 403 ohms. So this thing got toasted really bad. It looks like it runs very hot, and that seems to be the problem with this whole amplifier. All of the power resistors had heat stress on them. So I had to replace all of those. So what I did was, when I relocated the capacitor that was in here, that other 40 microfarad, it's now in this can, I moved that resistor this was originally here, going down to here. I put a larger, this is what I had in stock, so this is what I used. It's a way overkill, 10 watt, but it fit in there really nicely. So I put a 2.2K over to here of a much larger wattage, and then I relocated the wiring. There were two wires, one going down to here and one going over to here, and I put those, just put two new wires, and I used the PTFE 600 volt silver wire for that. I don't use that for a lot of things because it's really expensive, but it was nice and thin and good wire, so I put it in. Everything else got wired exactly the same. So the rest of these are all as they were. Other than that, that's pretty much the whole thing. Oh, and I replaced these pots, and I think I showed you about those earlier, and how we flipped those around, the little keys on them. So they're all mounted, and I statically measured the resistance of the old ones and set the new ones to the same resistance. I'm sure the bias and balance will be out a wee little bit from all these changes, especially from that 400 ohm resistor that should have been 2.2K. But hopefully now everything will be right in place. I have not powered this thing up. I checked it a couple of times. It looks to be wired properly. So really the only thing left to do is to power it up, and I'll do that on camera with you. And this time, if we get a puff of smoke, you'll get to see it. So let me hook up the meters, and we'll be right back. Okay, hopefully I have this all in frame. We're connected to our B+, our main B+, which would be going into the output transformers. And we're looking at our bias voltage right here. And we're going to see, I'm just going to use the dim bulb tester. I'm on limit through the bulb, and I do have a small fuse in the fuse socket, so I kind of, when I do go to main power, if there's anything really bad, it should pop the fuse. So and I got my kilowatt connected so I can monitor the amperage, and we're going to go from there. So here we go, turning on. This is going to be B+, this is going to be bias. So far so good. The dim bulb flashed, and now it's dimming way down, which is pretty good. We got 430 volts. Now I should see the bulb should start getting bright again as the tubes heat up, and there it goes. The bulb's getting bright. Tube is conducting, and that should be our 40 volts. Now I'm running through the dim bulb, and I am highly limiting, and I have 560 milliamps, which is all we're going to get with this light bulb in here. We're not going to get any more than that, than about half an amp. So what this tells me is all of the power supplies seem to be working. Now let's go through and check the other power supplies in with this. So if we go over to here, that's the next one. And if we go to this side, okay. 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 And okay. So they're all good. Nothing looking crazy. And again, they're all current limited right now, so they're going to be kind of goofy. I think it's safe to go to full power now, and let's see how far our bias voltage goes up. And I'm going to keep my hand on the dim bulb, so if something gets crazy, I can shut it back down very quickly. Okay. And it's climbing pretty big because it needs adjusted. But all in all, I'm just back into limit again. But all in all, it looks good. Now we're going to have to flip this over and adjust the bias and the balance and so forth. But the good news is, preliminarily anyway, it's working. Now, I'm probably going to stop this video here and kind of get some stuff uploaded. Okay, so here's the top side of the amp, and as you can see, the one problem that I told you about is this can capacitor. The old one that was in there was substantially shorter, and look at this thing, sticks up like a dick on a fish. Irritates me. What are we going to do? So I guess the only thing I can do is when I go to build the cover for this, of course there is no case for it, so when I build the case, I'm going to have to put a little lip on the frame on the top so that this will come up just enough. I mean, it's not a whole lot when you look at it. There's about a ½ an inch of height there. So we'll have to fix that. You can see the 220 microfarad caps in there and the new pots and the freshly painted transformers. That's all good. So that's pretty much where we are. So we're going to get this thing aligned and everything later and test it out. So just thought I'd show you where we are.